So for problem 4.6, it says that an electron leaves one end of a TV picture tube with 0 initial speed and travels in a straight line to the accelerating grid, which is 1.8 centimeters away. So its mass is 9.11 times 10 to the minus 31 kilograms. Distance is 1.8 centimeters away, and it reaches the grid with a velocity of 3.00 times 10 to the 6th meters per second. So part A says the acceleration. If the accelerating force is constant, compute the acceleration. So to compute the acceleration, it is the change in velocity over the change in time. And number B asks what is the time that it reaches the grid. So in order to do the first one, I'm going to calculate the second one. So to calculate time, the distance times velocity initial plus the final velocity times t, and this is over 2. So solving for t, we get 0.018 meters, because that was from our distance. So d equals that. And then we multiply it by 2 and divide by 3 times 10 to the 6th meters per second. And we get time is equal to 1.28 times 10 to the minus 8 seconds. So that's the answer for B. And so in A, I'm going to take the change in velocity, which is this 3 times 10 to the 6th, divided by my change in time, which is 1.2 times 10 to the minus 8. And that gives me an acceleration of 2.5 times 10 to the 14th meters per second squared. And for C, let's see. Okay, so A was 2.5 times 10 to the 14th meters per second squared. B was 1.28 times 10 to the minus 8 seconds. And C asks us what is the net force, so in newtons. So we know force equals mass times acceleration. So the acceleration that we found was 2.5 times 10 to the 14th. And our mass in kilograms is 9.11 times 10 to the minus 31. And that would equal a force of 2.28 times 10 to the minus 16 newtons. So that's it for 4.6.